Hi Year 12 Maths General students. This is a little topic test on Earth geometry and time zones for topic 4 of Unit 3 in the Queensland General Maths syllabus. This test has got 9 questions on it with simple familiar, complex familiar and complex unfamiliar. And I've written the questions based on the sample assessment that QCAA have released to kind of get used to the language that they're using and types of questions that we've seen so far. So at any stage, feel free to press pause and have a go at the questions. I will talk through the questions and then go through the worked answers as we go along. A copy of these questions can be found in the description below this video for anyone to download and use. Alright, question 1, simple familiar. Label the diagram with the following global features. So find where the equator is, what's a great circle, and where would be an example of one on the globe. Where's the North Pole, South Pole? Show me a line of latitude, a line of longitude. What would be a small circle example on the globe? Where's the prime meridian? Where's the international date line? And find me a point where the coordinates are 80 degrees west and 30 degrees north. Press pause and have a go. Okay, hopefully your answers look similar to mine. If you picked different examples, that's okay, as long as they're the same type of feature on the globe. So the equator, you can't have a different answer to what I would. Great circle is just you picking any line of longitude or the equator. So remember, great circle are they're a circumference around the whole Earth, and any of these lines of longitude or the equator is an example of that. North Pole up top, South Pole down the bottom. Lines of latitude, remember they are the horizontal lines and they vary in size. Lines of longitude, they're the ones that go around the length of the Earth, up and down. And you could have picked any one of these lines of longitude. Remember, they're all the same circumference. A small circle is any line of latitude except the equator, because remember the equator is the same circumference as one of the lines of longitude. Okay, so for small circle, you could have picked any one of these little lines of latitude. Prime meridian, this is at 0 degrees longitude. And international date line is on the other side of the prime meridian. And that's where we change days. And a point with coordinates 80 degrees west, 30 degrees north. So 80 degrees west, you're moving to the left of the prime meridian. So we get to 80 degrees west here. Then we go up to 30 degrees north. So there's 15, there's 30, so that gives us our coordinate on the Earth here. Okay, back to question 2, simple familiar. We've got a map of Australia here. You have to identify the approximate location of the town Cairns in Queensland. So have a look at the map. Where is it? Shout out to Cairns. That's where I used to live for a good 20 years. Part B asks you to then identify which town's located at approximately 33 degrees south, 137 degrees east. So see if you can spot which town that is. So press pause and have a quick go at those two. Alright, so hopefully you found Cairns up the top here. And if I kind of interpolate between our lines of latitude and our lines of longitude, then Cairns would have the approximate location. So you could vary a little bit off this depending on how accurately you're approximating. So I said Cairns is 16 degrees south, 146 degrees east. So remember, the latitude comes first, the longitude comes second. For part B, we had to find where 33 degrees south was, so approximately here, and then coming across to our longitude, finding where you think 137 degrees east is and going up to the 33 degrees south, and you'll find Adelaide there. Okay, question 3, simple familiar. Approximate coordinates of Washington, D.C., USA are 38 degrees 53 minutes north, 77 degrees and 2 minutes west. We have to then calculate the distance between Washington, D.C. and Lima, Peru. And Lima, Peru has the coordinates 12 degrees 3 minutes north, 77 degrees 2 minutes west. So if you have a look at your formula sheet, hopefully you're thinking about whether these two places have a latitude in common or a longitude in common, and go from there. All right, press pause and see if you can calculate the distance between them. Okay, so you should have observed that they have the same longitude. Okay, so they both have a longitude of 77 degrees and 2 minutes west. Because they have the same longitude, that means we use this particular formula on our formula sheet. So 111.2 times the angular distance. So remember now the angular distance is now the difference between their latitudes. So considering their latitudes, to find the difference between them, you can use your calculator to help you. So enter it in, 38 degrees, 53 minutes, minus 12 degrees and 3 minutes. So that gives you 23 degrees 50 minutes. To proceed with using the formula though, our degrees have to be in decimal form, okay? So at the moment they're in degrees minutes form. You have to convert them to decimal form. So all you need to do is to press the degrees minutes seconds button again, and it will convert it to decimal form for you, okay? So then it's just a matter of multiplying that by, and you'll get 2,983.87 kilometers. Question 4, simple familiar. Determine the shortest distance between Buenos Aires, Argentina, which has 38 degrees south, 58 degrees west, and Sydney with Australia, which has 34 degrees south, 151 degrees east. So we're looking at the shortest distance here. So you may need to consider the shortest versus the longest distance around the Earth between these two cities. And are we talking about same lines of latitude here or same lines of longitude? So have a look at that. You'll have to use a formula from your formula sheet as well, and check in very shortly with your attempt. Okay, how did you go? Hopefully you saw that these two cities have the same line of latitude, okay, and different lines of longitude. So this means when they have the same line of latitude, we have to use this particular formula from your formula sheet, where remember theta in this cos theta represents the line of latitude we're talking about. Okay, so using the formula itself, our theta is going to be the 34 degrees south. Angular distance, well, if you have a look at around the circumference of the Earth, the difference between them looking this way is 209 degrees. The difference looking this way is 151 degrees. And it said the shortest distance, so that means I have to use the 151 degrees. Okay, so if I sub all of that into my calculator, 13,920.54 kilometers. It says to the nearest kilometer, so make sure you read that carefully and complete it. So that rounds up to 13,921 kilometers between those two cities. All right, question 5 is another simple familiar. We're looking at time differences now. So calculate the approximate time difference to the nearest minute between these locations along the meridians. We're looking between 30 degrees east to 80 degrees east, then 120 degrees east to 40 degrees west. So the approximate time difference, that's referring to your recollection on what does 1 degree of longitude difference equate to in minutes. All right, so there's your clue. Have a go and see, and we'll check in to see how you went shortly. Okay, so hopefully you recall that any difference of 15 degrees longitude is equivalent to 1 hour time difference approximately, and 1 degree longitude difference is approximately 4 minutes time difference. Now remember, this isn't really the reality because of time zones that have been set up on the Earth, but this is how you would do this type of question. So if I consider the location of these two longitudes on the Earth, you always need to consider the prime meridian and the international dateline in case there's a crossover and you need to account for that. Okay, but we're good with this simple example. So there's an angular difference of 50 degrees. So that means if I've got 50 degrees and I'm dividing it by 15 degrees, that equates to 3.33 hours. If you want a more exact conversion, you can check it with your calculator. So 50 divided by 15 gives us 3.33 recurring hours. The cool thing about this degrees, minutes, seconds is you can also use it to look at time calculations. So that's equivalent to 3 hours and 20 minutes. So if you think about it, a third of an hour is 0.333 recurring, which is 20 minutes. For part B, we've got a little bit more of a complicated scenario here. From the prime meridian, we're going 120 degrees east and then 40 degrees west. So in total, the angular distance between them is 160 degrees. Okay, so if I take that into account, 160 degrees divided by 15 gives me 10.67 hours time difference, and I can use that to convert it into hours and minutes. So that's 10 hours and 40 minutes. And if you think about it, 2/3, which is 0.6 recurring, is the same as 2/3 of an hour. So 2/3 of 60 minutes is 40 minutes. All right, moving on to a more complex familiar question. We have a map here and we're told to calculate the approximate distance between Asyut and Tanta in Egypt. Not sure if I'm pronouncing those properly, but that's my best guess. And we need to do that to the nearest kilometre using the following map. So first point of this problem would be to find where those towns are. Then consider, am I finding a horizontal distance or a vertical distance? And then you should be able to hopefully clue on to which formula you would use from your formula sheet to calculate the distance. Okay, press pause and give it a go. Okay, so after you locate them on the map, it looks like we're finding the vertical distance between them. So we're finding the distance between 2 points on the same longitude. From the map, looking at the fact that this is 30 degrees east and this is 35 degrees east, I kind of interpolated that it was approximately 32 degrees east as the line of longitude. Again, looking at the different latitudes between them, I need to know the angular distance. So what's the difference in their latitudes to each other? So interpolating again, it looks like that's at approximately 31 degrees north. Asyut looks like it's approximately 27 degrees north. So if I do a little sketch and have a look at that on the Earth, like I've cut the Earth in half, then you should be able to go, all right, the difference in their angular distance is 4 degrees. Because I'm using the same line of longitude, I'll use this particular formula for my formula sheet, and then I just simply plug it all in, and that gives me a distance of 448.8 kilometers, which rounding to the nearest kilometer is 445 kilometers. All right, question 7. Determine the coordinates of Helsinki, Finland, if it's located 1,668 kilometers east of Aberdeen, Scotland, located at 60 degrees north, 5 degrees west, and both towns are on the same line of latitude. All right, so this one's kind of a working backwards problem. We've been given the distance between them. You need to then find the coordinates of Helsinki, Finland. You know that they're on the same line of latitude, so that means that their latitude will be the same. Okay, so think about which formula on your formula sheet you could use to work backwards. Okay, we're going to be finding the angular distance here between them. So give it a go. Draw a sketch of the problem. That helps a lot in these spatial problems. And we'll check in to see how you went. Okay, how did you go? If they're on the same line of latitude, that means I'm going to use this distance formula here, the one where I need to put in the cos of the latitude itself. So if I know on the same line of latitude, that means they're both on 60 degrees north. Okay, and I know the distance between the towns is 1,668 kilometers. If I do a little sketch, like you're kind of looking down on the Earth, you've cut it in half, and I'm looking here at Helsinki and Aberdeen, and I'm traveling east because it's east of Aberdeen, and that distance I'm traveling is 1,668 kilometers. Okay, so if I sub what I know into the equation, so the distance, the latitude, what I'm finding or solving for is the angular distance. So I evaluated the 111.2 times cos of 60, and that gave me 55.6. So then to get the angular distance, I simply need to divide by the 55.6, and that gives me an angular distance of 30 degrees. Considering that, if I'm traveling east, that means I need to take off 5 degrees to get to my prime meridian, and then add on another 25 degrees to get to Helsinki. So that means Helsinki, Finland is located at 60 degrees north, 25 degrees east compared to our prime meridian, and hopefully that's the coordinates you got as well. Okay, question 8 has a simple familiar and complex familiar component to it. We have Alexander working in New York, which gives you a time zone, so GMT minus 5. You need to write this time zone in UTC notation. Part B tells us that Alexander's mother lives in England, UTC of 0. If Alexander rings his mother on Tuesday night at 7:15 p.m, determine what day and time it is in England when his mum receives the call. In Part C, later that year, Alex's mum decides to fly to New York from England. Her plane departs Saturday morning at 6:30 local England time. So we need to take into account the flight time of 7 hours and 50 minutes, and then work out what time Alex would expect his mother's plane to pick up his mum. Okay, so this question is all about time differences. Let's see how you go. So press pause and give it a crack. Okay, so hopefully you recall that UTC is essentially the same as the GMT. So all you needed to do was write UTC minus 5. For B, the time difference between New York and England, so I'm considering minus 5 to 0. So that means that Alex's mum is 5 hours ahead in England. If in New York we're calling at 7:15 p.m., if I add on 5 hours to that, that gives me 12:15 a.m. on Wednesday morning. So if Alex is calling at 7:15 p.m. on Tuesday night, if I add 5 hours onto that, that means his mum is receiving the call at 12:15 a.m. Just past midnight on Wednesday morning. Now, if you're not great with time differences, you can use a calculator to help you. You can use the degrees, minutes, seconds, because degrees and seconds are in out of 60. So you can enter in times, so 7:15, so 7 hours 15 minutes, so 7:15. If you add on 5 hours, that gives you 12:15. So it's just a cool little trick you can use with your calculators if you're not confident with time. Part C, when considering these questions where we're looking at a time difference as well as travel time, there's two different ways you can approach the problem. The first way is to apply your travel time first from wherever they're departing from, and then to convert the time difference. Or alternatively, and this is the way I like doing it, is to firstly convert time into where they're traveling to first, and then applying travel time to that. So if she departs from England at 6:30 a.m., if I consider the time difference there, that means she's departing New York time at 1:30 a.m. So checking it with your calculator, 6:30 minus the 5-hour difference gives us 1:30 a.m. in New York time. So I'm keeping everything in New York time. Now what I need to consider is if she left 1:30 a.m. Alex's time, there's a travel time of 7 hours and 50 minutes. So if I add that onto his current time, I end up with 9:20 a.m. on Saturday morning. So checking that with the calculator. So I've got the 1:30 a.m. add on 7 hours and 50 minutes of travel. That gives me 9:20. All right, last question. Complex, unfamiliar. We have Betty and Mark planning to meet in Darwin. Maybe it's a romantic rendezvous, who knows? So they're meeting in Darwin, Australia at UTC +9, and they're both traveling by plane. Betty lives in Riyadh, don't know if I'm pronouncing that properly, in Saudi Arabia, which has a time zone of UTC +3. And Mark lives in Winnipeg, Canada, UTC -6 time zone. So we're told that Betty's plane departs on a Monday at 8:30 p.m. at her local time in Riyadh and takes 17 hours and 20 minutes. Mark's plane departs on Sunday at 7:15 p.m. in his local time in Winnipeg, and flight time is 29 hours. Determine who will arrive first, so I'm assuming that's in Darwin, and how long they'll be waiting for until the other person arrives. So think about the advice I gave you earlier. At some stage, convert everyone's time and travel into one time zone, and then that will make it a whole heap easier. All right, give it a go, and we'll check in to see how you went with your attempt. All right, so look at each person's travel separately. So from Riyadh, Betty's time difference, Darwin is 6 hours ahead of where she's currently at when she jumps on the plane. So what I'm going to do first though is I'm going to convert everything into Darwin time. So if she departs Monday 8:30 p.m. in Riyadh, that means the plane's departing at the equivalent time of Tuesday in Darwin at 2:30 a.m. Then all I need to do is add on her flight time. So 2:30 a.m. plus the 17 hours and 20 minutes means she lands in Darwin at 7:50 p.m. on Tuesday. Remember, I can check these with my calculator. 8:30, add on 6 hours, gives me 14:30. And you guys know in 24-hour time, that's 2:30. Considering that I can't have a 14:30 time, remember she's leaving 8:30 at night. So we've passed midnight and we've gone into the next day. So we've gone in by 2 hours and 30 minutes. So you can interpret that kind of similar to 24-hour time, except we're talking AM here at 2:30 AM. If I then put in the fact that I'm working with 2:30, I'm adding on 17 hours and 20 minutes of flight time. That puts me 19:50. So considering 24-hour time again, 2:30 a.m. plus 17 hours 20 minutes. So remember 24-hour time, 19 represents 7 p.m. So that's 7:50 p.m. Now considering Mark leaving from Winnipeg, there's a 15-hour time difference there. So I'm going to convert when he departs into Darwin time. So if he departs at 7:15 p.m. on Sunday in Winnipeg, that's the equivalent time in Darwin where it would be Monday at 10:15 a.m. Again, you can check that. So 7:15 plus 15 hours. So you can see that puts us 22:15, and similar thinking, not quite 24-hour time here because we're going from PM through to AM, although we know that 22 in 24-hour time is equivalent to 10. So you can look at it that way if you like. So regardless of that, we're talking about Monday 10:15 a.m. Darwin time. Considering his flight time then, it's 10:15 a.m. Monday in Darwin, add on 29 hours there. That will give us him landing 3:15 p.m. on Tuesday in Darwin. So if I compare the two, that means that Mark will arrive first, and considering that time difference, that's a time difference of 4 hours and 35 minutes. So if I firstly check the 10:15 AM depart time, 29 hours, so that's a whole 24 hours plus another 5 hours. So if I add on 5 hours to that, that gives me 3:15 p.m. in the afternoon, thinking about the fact that that's 24-hour time. Then checking the time difference, I've got 7:50 minus 3:15 gives us 4 hours and 35 minutes. Okay, how did you go? Hopefully by doing these questions, that's given you a bit more confidence with Earth geometry and time zones, and you feel raring and ready to go for any assessment that's coming up. All right, good luck with it, and thanks, Year 12s.